Assalamu alaikum, my name is Amjad Abdullah and I'll be presenting today Group 1 in this video. I'll be speaking and summarizing about some key concepts in parallel computing under our title, which is The Future is Parallel. So before, if people wanted a higher performance, they would simply do such a thing as buying a faster CPU with a higher clock speed. Well, that used to be enough because higher gigahertz meant more speed, right? And everything just felt faster. But that doesn't work anymore because over time we reached this point where pushing a single core to higher frequencies caused us too much power consumption and heat at the same time. So if you go anywhere higher, the CPU becomes unstable. And this physical limit is called the clock speed wall. So as a solution, instead of trying to make one core run faster, the idea or the new way became to use many cores working together. And this new way leads us to two simple ideas that people often confuse, which are concurrency and parallelism. So in simple words, concurrency is one worker switching between jobs, or in other words, one core switching between tasks. And that gives us the illusion that it might be parallelism or simultaneous work, which is incorrect because parallelism is many workers or cores doing jobs at the same exact time. And with this true parallel performance, we break the clock speed wall. Now, when we talk about parallel work, there are two very simple types. We have data parallelism, which is data focused. So you apply the same task or operation to many pieces of the data itself at once. In simple words, we say many data, but same work or same task being applied. And in the other hand, we have task parallelism, which is the opposite. It's task focused, which means we perform different tasks or different operation on the same data flow at the same time. So in simple words, we say one data stream and different tasks or different operations or work. So with mentioning data parallelism and task parallelism, we have to bring CPU and GPU into picture. First, we can see the CPU as a small team of highly skilled specialists, which are the cores doing powerful, complex tasks. And the CPU is great for task parallel work, where each core handles different complex jobs. And for the GPU, it's like having a massive army of simple levers or cores, and it's built for data parallel work, which means applying the same operation to huge amounts of data simultaneously. And that's why GPUs dominate graphics and machine learning. And with all of that finished, we can see that hardware isn't enough. There's something missing. And in this scenario, we cannot arrange a team without a manager. So we need a software for that. And this is where Bthreads and OpenMP come in. First, Bthreads, you create threads, assign work, handle synchronization yourself. So it's all manual and it's all low-level approach. While it gives full control, but it's complex, so you have to deal with every worker or thread individually. And OpenMP is the exact opposite. While the Bthreads is low-level, OpenMP is high-level, and it's not manual, it's automatic. And its approach is very simple. It automatically creates threads, splits the loop, and handles synchronization. And it uses things later on like critical sections, atomic updates. So in summary, if you want manual low-level control, you use Bthreads. And if you want something simple and fast, you use OpenMP. At the end, we can see that the future isn't one worker or one core running faster. We can say that the future is many workers or cores running at the same time. And thank you for watching.